Hello, and welcome to the Generative AI Hackathon. I'm Ed Grefenstette, Head of Machine Learning at Cohere, and today I'm here to talk a little bit about generative AI, what it is, why you should care about it, and the sort of stuff that, hopefully we're going to help you build during the next few days. So to jump right in, generative AI is the subfield of artificial intelligence that deals with using and designing and creating generative models. And generative models are statistical models that allow you to sample or generate some data from a particular domain. So, for example, text from one or more languages, images, code, etc. During the rest of this talk, I'm not going to really go into the math or mathiness of these models. And so if that part of generative AI is something that you are not very familiar with, don't worry about the mathematical language surrounding this. You can think about these models as black boxes that you can produce new things from, images or text, perhaps controlled or conditioned on inputs that you provide to the boxes. And so these statistical models, these black boxes that you sample from, that you generate from, encompass the regularities or the patterns or other information from the domain. Commonly, they are large neural networks that are trained by consuming data which exemplifies these regularities or these patterns from that domain. And the nice thing is that thanks to companies like Cohere, Stability, OpenAI, you don't actually need to understand how this is done, how these models are produced, how they work internally in order to use them. Although it doesn't hurt if you do understand this, because it will give you strong intuitions about what their strengths and limitations are and how to get them to behave how you want. But hopefully part of this talk is going to give you at least some of these intuitions and help you get started. The data that you put into these models when you're training them affects what they're going to be good at generating. So, for example, a generative model learned from English text as input data when we're training it is going to be good at generating more English text. Probably not going to be good at generating Korean or images or Python code. Conversely, a model that's trained on images is probably not going to be super good at generating text. A generative model learned on a sort of subdomain of one of these modalities, for example, predominantly learned from legal text, is also going to be good at generating more new legal sounding text rather than perhaps, conversational chat about, mathematics. Now, the process of being able to take a black box and sample new images or new text from it sounds pretty cool, but on its own, that's not very useful because you probably want to direct the model towards the sort of thing that you want it to generate, the sort of like thing you want to create. And so that's where we come into this notion of conditional generation. Remember, I said these models can be thought of as black boxes which you can provide some conditioning input to. So conditional generation is this very notion. It's the process of generating something from the model conditioned on something else. For example, generating an image given a text description of the image you want to generate. Given the start of a paragraph, generate completions of the paragraph. Given some instructions, produce responses that execute the instructions. Now, why would you care about generation or conditional generation? Why should we be, learning about this in order to build things? Well, it turns out that many or perhaps most intelligent tasks that we do as humans in our jobs and our daily lives actually fit this pattern of conditional generation quite well. For example, drawing a picture given an idea that you have, whether you verbalize it as text or you have it in some sort of conceptual space in your mind, is a form of conditional generation, as is deciding what to say next in an everyday conversation given what's been said so far and the sort of broader context of the conversation. Providing advice given the description of a problem, or writing an effective, efficient computer program given some specification or some goal are also good examples of this. Really anything where, you have information about the world or about the particular context, and then you need to act to produce something in return actually is a form of conditional generation. So the possibilities are really endless if you have powerful generative models capable of conditional generation. Today, we're going to be focusing primarily, or solely, in fact, and for the next few days, on text generation, which is the process of generating more text given some other text, conditioning the generation itself. Now, you're not going to need to worry about the training or spinning up or serving of the models, the large neural networks that are capable of doing this for you. And instead, we're going to be using Cohere's models. And since I'm assuming you have a certain degree of freedom as to what you do during the hackathon, you can use whatever other tools and generative models you can find if you want. But Cohere's models are trained and served via endpoints with language-specific SDKs, such as a Python SDK available for your convenience, and they allow you to do conditional generation of over English currently, and eventually other languages as a modality. So there are two components to this process of getting text out of a model. There's the prompt, which is the element which you, the developer, give to the model, and that can be something that you've handwritten. It can be something that's dynamically produced based on the user input of your application or service. But that's the element that you have control over, which conditions the model towards producing a particular kind of generation. And then the generation itself, what you get from the model in return for your prompt, is what we refer to as the response. So how can you prompt your model to do things? Well, unmodified large language models respond to prompts by continuing them in most cases. So you can think of this as a very fancy autocomplete. Prompting, for example, a model with the prompt. The cool thing about machine learning is implicitly will obtain continuations such as are shown in this little code snippet I typed in using Cohere's API. So it completed that sentence as the cool thing about machine learning is that the algorithms will always be learning and improving as they're exposed to more data, which is true. So this exemplifies the ability of the large language model to continue my sentence beyond just a few words until the end of sentence, in fact. You'll note here in the call I made that I told it, gave it a stop sequence. I said stop generating when you hit a full stop. If you remove that and you increase the max number of tokens, you can generate entire paragraphs. You can write your entire essay. Obviously, there's the potential for the generation to go off track as it goes along, but that's something you'll have to learn by experimenting with it. But it's astounding that you can produce these full sentences, full paragraphs that continue the style and topic of the prompt you give them. But beyond just treating them like fancy autocomplete, you can also, in a sense, teach them the reason through examples. So because they want to, these models want to continue to slightly anthropomorphize them. They want to continue the patterns that they see in your prompt. If you give them a pattern that has some structure, like here I go for this pattern of some data, a line that has a query, that's the index of the word I want to return, and then the result is, in these examples, the correct word to be returned. So I gave the model through the prompt a number of these examples of querying into a string. And the final such example is a new sentence that wasn't anywhere else in the data. I'm looking for the fourth word, which is actual. And I prompt the model, I finish the prompt by saying result : and then telling the model complete this entire sequence by giving me what the next word should be. And then when I run it, I see here that it does the right thing, which is that the prompt is quite long and the response is quite short, but it is in fact the correct word. And this is an example of how, without further training of the neural network, just through the structure of the prompt, science we call prompt engineering, I can actually induce this fairly structured behavior in the model with something it's not at all trained to do through a few examples. And that's quite a powerful ability that these models have. So this notion of being able to teach them on the fly through examples is powerful, but it might not seem extremely natural. We're used to talking to one another in goal-directed situations by giving each other instructions. So ideally, you'd sort of want to just be able to tell the model what it should do. So could I just not just tell my model what to do, give it instructions? And the answer is no, but yes. No, in the sense that most of the basic, even large, high-performance language models are trained to continuous sequence, as we've seen. So to get them to behave in a particular way, you have to prompt them by induction or analogy, as we've seen in the previous example. They're not trained to take an instruction and then actually understand, interpret, and execute the instruction. But there are specialized variations of these models, like InstructGPT, OpenAI DaVinci, or Cohere's own new command model, which you'll have access to during this hackathon, which take instructions as prompts, and the behavior is significantly different. For example, I can give the model as a prompt, write a 3-sentence paragraph about how machine learning can be used to generate language. The code that I wrote here is very similar to in the other examples, except as a model now I specify command x large, which is our command model. And when it reads this instruction, it produces as a response something that isn't naturally a continuation of this so much as it is actually following the instruction by writing exactly 3 sentences and then stopping. Note that these models actually do have a pretty good internal notion of when to stop based on the instruction, so you don't actually need to give them stop sequences. It automatically stopped after emitting 3 sentences. You can even ask them to do more procedural things like count from 10 down to 1, skipping all multiples of 4, and it almost does the right thing. So it skips 10. Obviously, I forgot to mention that, but it skips 8 and 4 correctly and somehow skips 6, which it thinks is a multiple of 4. So it's good to be aware that these models aren't sort of oracles, but that it's almost roughly following the instruction with no sort of actual example, just from its internal knowledge and ability to interpret such instructions. You'll note that for domains like this, where the instructions are pertaining to something much more formal and structured rather than exploiting the regularities of natural language like English, that there's scope for mistakes. So it's good to bear that in mind, that they'll work significantly more robustly at instructions about language than about sort of data. But it's surprising and quite magical that they do so well on even these sort of like very data-centric prompts. So to wrap up, where should you go from here? Well, you should experiment with which form of prompting that we've discussed suits your needs and suits your project, and how to form and manipulate prompts and responses based on what you're trying to achieve and how you're incorporating user input, etc. But ultimately, because it's just text in, text out, you have an astounding amount of freedom here with regard to how you're going to incorporate these calls to large language models, this ability to generate text condition on other text and manipulate its meaning, its structure, its ordering, and how you incorporate this into your projects. So, as I just mentioned at the end of the previous slide, it's good to have this caveat that these are not magical know-all models, right? But provided you're conditioning them on something which exploits their knowledge of the regularities of language, specifically English in the case of these models, the results really can't seem magical. You can produce processes which almost do seem to understand the language, and baking that ability into the applications, into the services, into the perhaps the products that you want to build really unlocks a whole new dimension to play with, and to get creative with. So I really look forward to seeing at the end of the hackathon the cool stuff you all have built. But yeah, go at it and happy hacking. Thanks.